About that form, fill it up. Do that sometime, maybe do an average. I could go online and maybe print out another one. I have it saved on my, or actually I have it seen on my computer. I can put it on my drive and print out one.
I can just do it. I can do it from my office. I just have to. I've got it in my email, so it might be easiest for me.
Oh, perfect.
Okay, so before we start, I have an announcement to make. So a student in this class is in need of a note taker. If you take clear, legible notes and are interested in volunteering as a note taker, please contact me after the class, and we'll arrange for you to be a note taker. So again, a student is in need of a note taker. If you take clear, legible notes, let me know, and we'll set you up as a note taker for this class. And for those of you who came in, so again, for those of you who just came in, the lecture videos you found here. Okay, so this is quiz 3 from last Thursday. So here's the mistake I made. I forgot to put an oxygen right here.
We help ourselves and help others.
Different compound there? Yeah, so the way it was, if there was a hydrogen here and not the oxygen, it would be a different compound because they're supposed to be structural isomers. Okay, so these two compounds here are structural isomers. Without that oxygen, then the chemical formula is different, therefore they're different compounds. Okay, so anyway, I didn't grade question 1 since I made a mistake on that. For question 2, how are saturated fats similar to trans fats? So a saturated fat has carbon-carbon single bonds only, whereas a trans fat is a type of unsaturated fat, which means it has at least one carbon-carbon double bond. Okay, so let me write this. So fats can be classified as either saturated fats or unsaturated fats. For the saturated fats, these have at least one they have all carbon-carbon single bonds. For unsaturated fats, it has at least one carbon-carbon double bond. And note that there's two isomers. One are the cis fats, the other the trans fats. The trans and the cis. So note that the cis and trans are types of isomers. Are they structural isomers or stereoisomers? Cis and trans.
Stereo.
Yeah, those are stereoisomers. Now note that with the trans fats, okay, with the trans fats, these are similar to saturated fats in that the shape is straight. Whereas with the cis fats, note that because of the cis orientation, there is a bend. So these molecules bend. Okay, so these cis fats are bent. and trans fats are straight, just like the saturated fats are straight. And because of that structure, that straight structure, the saturated fats and trans fats can pack together closer together, and the result have a higher density, and the result have a higher melting point. Okay, so these have higher densities, and these have higher melting points. Which means with the higher melting point, these tend to be solids at room temperature or at body temperature or both. Okay, so that's how saturated fats are similar to trans fats. So that's why if we're eating foods, it's actually better to eat bent foods than straight foods. Okay, then for question 3, 500 grams of sugar can be dissolved in 1 cup of water. Now I actually looked this up. This would actually make a saturated solution of sugar and water. Explain why sugar is soluble in water. Now sugar, the chemical form of sugar is C12H22O11, so you have a sugar-water solution. What type of solution is this? Is it an ionic solution or a molecular solution? And how do you know it's a molecular solution? So it's a molecular solution because? Yeah, because sugar is a covalent compound or molecular compound. Okay. So if it's a molecular solution, do we look at hydration energy and lattice energy, or do you look at intermolecular forces?
Intermolecular forces.
Yes, you want to look at intermolecular forces. So last week we said that a solute, if you have a molecular solution, the solute is soluble in the solvent because both solute and solvent have similar intermolecular forces. And in this case, the intermolecular forces involved would be which ones? Yes, it'll be hydrogen bonds. Okay, so that's question 3A. For 3B, how can you get more sugar to dissolve in water? So one way to get more sugar to dissolve in water is, you raise the temperature of the water. And is there another way?
Increase the amount of H2O?
Yeah, add more water. Okay, are there any questions on quiz 3? Okay, now before I forget, on for Thursday's lab, you'll want to bring 2 sodas. Bring 2 sodas to class. So, it doesn't know, well, I guess you should bring since we're doing experiments, you should bring the same soda, and if it's a canned soda, bring 2 canned sodas, or if it's in a bottle, bring 2 bottled sodas. Okay, so bring 2 of the same kind of soda. Because we're going to try to figure out what is the pressure of CO2 gas in the soda, and see if that solubility stuff that we've been talking about the solubility of gases and liquids holds true. So anyway, what is the solubility of gases and liquids? So as you increase the temperature, does the solubility of gas increase or decrease? So you're saying as the temperature, okay, so let me write this down. As you increase the, okay, so as you increase the temperature, as T goes up, you're saying that the solubility of a gas does go up or down?
Down.
Yeah, it should decrease. Okay, so if you warm up, and you may have seen this before, if you're boiling water to make your coffee or tea, and you have, say, say a glass tea kettle, you'll see these little bubbles start to form when they start rising and coming out of solution. So those are, what are those bubbles there in water? Yeah, a little bit of CO2, but it's actually more of the oxygen. Yes, these are oxygen bubbles coming up out of it. So you heat up, you see these bubbles form, that's oxygen. Oxygen is dissolved in water. Okay, let's see. Let's go back one slide. Let's do questions 4 and 5 here. We talked about these colligative properties of solutions, and for these colligative properties, okay, so these colligative properties are properties of a solution. These colligative properties depend on the concentration of solute in the solution. Okay, so these properties depend on concentration. So there are 4 colligative properties that we're going to look at. And we took a brief look at these 4 properties last week. And what were these 4 colligative properties? Yeah, so one was freezing point something. No, that's actually boiling. Yeah, freezing point depression. So that means that if you add a solute to a solvent, the freezing point of that resulting solution is going to drop. It's going to be lower than the freezing point of the pure solvent. And another one had to do with elevation. Yeah, so this is boiling point elevation. So if you add a solute to a solvent, the boiling point of that solution is going to be higher than the boiling point of the pure solvent. And then there's 2 more. Melting point? No, that's actually the freezing point. Oh. What kind of pressure? Okay, yeah, so osmotic pressure is another colligative property. So with the